This is part 2 of Advent of Code, day 22. In this second part, we have to take the game from part 1, which was a game of combat that we played against a crab, and we need to add in some extra rules to make it recursive, because the crab had the upper hand in the first part, and we want a chance at winning here in this second part. So the rules that we have to add are, first, a rule that guards against playing infinitely recursive game. So if at any point during any of the rounds, both players' decks match the way those decks looked earlier in a round from that particular game, then we end it and player 1 wins. Otherwise, things proceed mostly as usual from the rules before. If I have a card that's higher than the other player's card, then I win, and vice versa. The only exception to that is if at a certain point the both of the cards that come out are both values that are less than or equal to the number of cards left in our respective decks, then we would enter into a recursive round of combat. So to see an example of that, let's look at, so here's play proceeding as normal. A 9 and a 5 come out, player 1 wins, we go on. 2 and 8 comes out, player 2 wins, those go there, so on and so forth. But we keep going. There's a 5 and a 2, but there's only 4 cards remaining, so this is still a regular round where player 1 wins. 6 and 7, and then eventually we get to this hand here, 4 and 3. There are 4 left besides the 4 in player 1's deck, so it's less than or equal to the value of that card, and 3 is the card that player 2 drew, and they still have 4 remaining, so that's also going to meet that criteria. So we enter into a subgame, where we copy over our remaining decks and continue to play from there. So now I have 9, 8, 5, 2. Player 2 has 10, 1, 7. I'm not sure what happened to the 6 there. I wonder if that's a typo. But anyway, play would proceed. 9 and the 10. Player 2 wins. And so then this game 2 that we're in, this subgame, game 2, would continue until one of the players wins, which is here at this point. Player 2 snags the last card and now has a full deck. So they win game 2, which means that we exit out of this subgame and return back to game 1, where the winner of this game determines the winner of those sets of cards up here. So this 3 and 4 that we started with, that entered us into the subgame, player 2 is now the winner of that because they won the subgame. And so they take 3 and then 4 below it on the back end of their deck, which we can see right here. The 3 and the 4 show up. I'm seeing the 6 still here now, so I'm wondering if the rule is that you take the number of cards off of your deck copied over equal to the size of your... Right, so this number 3 is the value of the card. We take that many cards off the top of our deck to play with in the subgame. I think that must be the rule. Make a copy of the next cards in their deck. The quantity of cards copied is equal to the number on the card they drew. Okay, so that's what happened to the 6. So play proceeds like this, so on and so forth. I think eventually in this example they enter, they get 3 games deep, and then they pop back out, and I'm going to keep scrolling. Eventually, player 2 whittles down player 1 to no cards, and player 2 is the winner. And then we would count the score in the same way as part 1, taking 3 times 1, 9 times 2, 8 times 3, all the way up to 7 times 10, and then summing all those values up. So we'll be able to reuse some of our solution from part 1, and we'll just have to make some modifications to the rules. So I am going to go ahead and save this as part2.rb. And yeah, I think all of the file parsing and the deck setup is the same. It's just this while logic that's going to have to change a bit. We're going to have to make something recursive. Yeah, I guess I kind of want to handle, or I want to think about handling the first rule, which is if there's ever a point where the two decks are the same in one round as they've been in a previous round for that game, then you need to terminate the game. And so I guess I'd like a way of representing a game so that as we go into sub games and then return to previous parent games, we have some sort of object that's representing that. So I'm going to say class game, and we're going to initialize this with, I guess, yeah, I guess if we were to pass in the cards we want to use, or the hand, so hand 1 and hand 2, that would suffice for then initializing. I guess hand 1 and hand 2 will be a stack of cards. Okay. So yeah, we'll say hand 1, it's hand 1, hand 2, it's hand 2. So we've got some instance variables there. And then I think we'll also want to keep track of hands this game. Something like that. I don't know if that's the best naming for it, but essentially want to keep track of the hands that we see each time. Okay. So yeah, what do we do once we have a game? I guess in a game you want to resolve next hand, resolve next draw, something like that. And that would, I guess, tell us to say hand 1 dot draw, hand 2 dot draw. I think this is where some of this logic is maybe going to come into play. So let's pull that up and see if we can mold this to our needs. So we bring both of these cards into play. And then, yeah, I think the first thing we said we wanted to do was store the current hand in this value, or to like check if it's already there. So perhaps we do the check if these hands have already appeared. And so we'll do that by saying hands this game, and we'll basically look up yeah, we want a way of like serializing hands 1 and 2 so that we can reference them. Yeah, let's see. I'm going to pry and see if we can come up with a strategy for that. So scene hands gets this hash. Let's say H1 is this and H2 is this. So then say scene hands, does that have this tuple H1, H2? No, that's no. Great. So then we'd like to set that to be true, I guess. So now seen hands, we've seen that once. So then later on, if we have seen hands 1, 2, 3, seen hands with 3, 4, 4, 5, 6. Yeah, then that returns true. So we can just do it like that. We can stick these the array values that are represented by the hand in there as a tuple to represent sort of a key that tells us whether we've seen that hand before. So we'll say hand1 dot cards, hand2 dot cards. We'll always check hand1 and then hand2 first in the tuple. Yeah, so maybe we'll give this a name like current hands. Something like that. And so if that's true, then we're gonna, I guess, raise and what do we want to call this? Class recursive game detected standard error. And so then down here, we can raise recursive game detected. Yeah, is that gonna add an empty line after the guard clause? Oh, I see what it wants. Okay. So we check that. If we don't raise, then we do want to register it now. So we'll say hands this game gets current hands, and that'll be set to true. So now we mark this as seen, and then we can proceed forward. So at this point, we pull the next two off, and we have two cases we need to consider. The first case is, do we need to go deeper into a subgame? And so we determine that by checking P1 is hand1 dot cards less than or equal to P1. Oops. Is hand2 dot cards less than or equal to P2. If both of those are true, then go to subgame, and that's where we generate a new game and proceed from there. Otherwise, we want to resolve as usual. Resolve cards as usual. And so that's how this bit, I think, would still play out. So we'll say hand 1 there, hand 2. Okay, and so those will just keep updating, and that will end. Okay, I'm liking the looks of this. I think resolve next draw is a good mechanism for this. We're going to need some sort of recursive function, though, going on here. Let's get rid of this code. Count of turns, we'll keep that around for now. Oh, let's see. Play recursive combat, and we'll give it hand 1, hand 2. And it's at this point that we say game gets game new, hand 1, hand 2. And then we let's see, do we play, I mean, I guess we call resolve next draw on the game until it what's our terminating condition? I guess that's what I'm missing here. Resolve next draw. I mean, this raise is a good terminating condition if yeah, I'm trying to see where the game and the game object and the recursive function, like how those are going to play together. And I think I've got those mixed up in my head at the moment. So let's see. So to play recursive combat, you need to I mean, we need to tell the game to game.resolve next draw. And this is either going to return an error, it's going to raise an error, or it's just going to do one exchange of cards in return. So then how does it recurse? Yeah, maybe what I'm struggling to figure out is this step 1 here. I mean, we can uncomment these. So I guess this isn't strictly code. We've got pseudocode here, so let's see, hand 1 cards is less than or equal to, and hand 2 cards. Then if that's the case, then we want to yeah, I mean, then we want to generate a new game. So we want to generate a new game, play the game out until there is a winner, report back the winner, and update the decks accordingly, meaning that if player 1 wins, then hand 2 dot, or hand 1 dot add to deck. Add to deck gets P1, P2. If P2 wins, then add to deck gets P2, P1. And then we would skip this instead. So it'd be either this or be this. And yeah, maybe resolve next draw going inside the game wasn't the best place for this. I'm not sure. Yeah, maybe this could still work. We'd say game dot new, say hand one dot I guess we need a new stack here. So stack of cards dot new hand one dot cards dot first P1. So we just want the first, if that's 3, we just want the first 3 cards. Okay, so that'll be hand 1, and then hand 2 will be stack of cards new hand 2 dot cards dot first P2. Okay, so we'll generate that new game. And then, yeah, resolve next draw. Maybe it's not resolve next draw, but it's resolve game. And resolve next draw. And so what is it? Result. Maybe we get some sort of result from resolve next draw. Or heck, we could even call this just a, our sub game. We get a result from sub game dot resolve next draw. And so if result equals like winner or player 1 wins, then we do one thing. Yes, we need a case statement here. Case result when player 1 wins, then do one thing. When player 2 wins, do another thing. When in progress, I guess, then call, and I guess result gets subgame.resolve next draw. This is where the recursion happens. Or rather the sort of iteration happens here. This creation of the subgame is the recursion, because then the subgame could get into this loop where it then creates its own game. Yeah. Okay. Are those the only 3 cases? In progress, player 1 wins, player 2 wins. Otherwise, we get a raise, which will bubble all the way up. So we update the deck and then return player 1 wins, turn player 2 wins, otherwise we raise an error. Okay. So we're going to need to end over here because that's going to match with this if. And yeah, we'll just update result. When it's in progress, then the result gets this. Okay, while I need a while somewhere, but I'm trying to think where, because you want it to go while the game's still in progress, like keep playing. So maybe the result just initializes to in progress. Then we say while result is in progress, we do all of this. Oh, but then we're not going to hit these. Okay, I take that back. We're going to put this here. While result is in progress, we'll do the in progress stuff like that. And then outside here, we'll have our case statement where we don't care about in progress because that'll be handled above. When player 1 wins, then we do this. Okay, this is coming together now. When player 2 wins, we do this. Oops, player 1. Okay, and then we'll X out of this if. That's an end. How about an else? And then our other end can go down here. We'll indent all of that. Okay. Yeah, I think that's going to play nicely. If we're entering a subgame, then we create the subgame. We get the result. We keep going until eventually it results in player 1 or 2 winning. We update the hand of the current thing and return. If we ever have an infinite loop situation, we deal with that up here. Yeah, I think that's gonna work. Okay. So then down here, I don't think we really need to say play recursive combat anymore. We just need to initialize it. We need to call game dot resolve next draw. Now I'm wondering if we do need a recursive element like play recursive, and here we just call, I don't know, resolve next draw, and yeah, like we just call while resolve gets resolved next draw, so that'll give us either in progress or player 1 or player 2 wins, while result dot while result is equal to in progress, we resolve next draw. We'll update result like that, and we'll keep going. And then eventually we'll return the result. And at that point, hand 1 and 2 should reflect whatever they need to reflect. And so then instead down here, instead of that, we can say, yeah, subgame dot play recursive until it gets a result. Okay. So this will return so that's player 1 wins the hand, but that's not player 1 wins the whole thing, like the other player's deck is empty. I think we're missing that part 1. How did that termination happen? Here we go. It was while the hands are empty, or not empty, you keep playing. So we need something like that. Okay. Oops. Part 2. Okay, so maybe that's what's missing here. We can update each of these, but so we update hand 1, and then return player 1 wins if hand 2 dot empty. Otherwise, it's still in progress. Similarly, you return player 2 wins if hand 1 is empty, otherwise it's still in progress. Maybe that's the trick to getting that recursion. Okay, and so yeah, that'll loop until it's no longer in progress. Then we'll get the result. Then down here we can, not going to worry about the count of turns. We'll get the final hands here, some of the results, and should have something to go off of. So we'll say Ruby part 2. Undefined method less than or equal to for array on line 52. Okay. Oh, cards dot size. Okay, well that ran to completion. We got 3,891. Is that the answer to part 2? No, the answer's too low. It's the right answer for someone else. No, I'm definitely not logged into someone else's account, so we didn't do something quite right there. The resulting hands, yeah, ultimately, I think they're going to come out here like mutated from whatever the game did to them, you know, as it played. So I expect these to return values that are different. We get the final hand, and then we sum them up. I wonder if we're missing anything else there. Scroll down. It's calculated from the cards they have in the original deck using the same rules as regular combat. It's calculated from the cards they have in their original deck. That's interesting. 291. So does this sum up to 291? So maybe I don't need to use the resultant deck, but I need to use the final deck. So is it final hand, reverse, each with index? Okay. So we'll say item times I. No, that's 291. And that's 75. Right, this wording's the original deck. I don't like that wording too much. Now that's different than saying this is their original deck. Okay. Well, I don't think I'm missing anything from the description down here, at least. If I scroll up a ways, is there anything I'm missing here? Yeah, I mean, we leave the sort of parent game, we leave those decks intact while we play the sub game. So those don't have any bearing on those cards. It just tells you where the cards then go afterward. I think we're doing this. We're just taking the winner's card first, not necessarily the higher valued card. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing. Yeah, so that's the recursive. Otherwise, at least one player does not have enough cards left in their deck to recurse. The winner of the round is a player with the higher value card. Yeah. So I think all that's happening. Here, let's clean this up. Let's see. So hand 1, cards that size is less than or equal to P1, and hand 2, cards that size less than or equal to P2, then we play a sub game. Sure. Doesn't like that comma. Yeah, here we take player 1 wins the sub game. then they get their card and then the other player's card at the bottom of their deck. If player 2 wins the subgame, then they get their card and the other player's card at the bottom of their deck. And oh, then what happens here? And else. Ooh. I think this is going to have a nil return value, or it's going to return this array. That could be a problem. If this subgame ends, then what needs to happen? I guess then we return in progress. In progress. Because now we've determined a winner and the current game keeps going, right? Because then resolve, next draw is going to have a result here. Does that make any difference? Wow, that's the exact same answer. That's not what I was expecting. That would have made a bigger difference. So if we go in this path, we just weren't returning anything before, or at least not a result, not a symbol. If we hit the else, we turn in progress, or we raise an error. That's fine. Oh, we did a draw up here. Are we also doing we're not doing a draw down here. Okay. So perhaps what needs to happen is this whole series of checks needs to happen outside of all of this if-else nonsense. So if hand 2 is empty, player 1 wins. If hand 1 is empty, player 2 wins. Otherwise, in progress. Okay, let's try that. Still the same result. Okay. Current hands, add it to the thing. We pull those values out. Yeah, it just doesn't like the complexity. That's why it's highlighting it. Okay. Yeah, either we've got a winner for the current game or we're still in progress. And we decided that while the result of resolving the next draw, while that's still in progress, we want to keep resolving the next draw. Are we calling play? Oh no, okay. Play recursive. I think that's what we were missing. Wrong number of arguments given to expected 1 for add to deck. on line 17. Oh, did I miss? Line 17, but where did it get called? Line 99, I guess? Or 35? So it's an add to deck call. Oh, sure enough, here. Oops. These need to be tuples, or this needs to be an array, not two different arguments. Comparison of integer with nil on 52. Okay. Oh, why would we get here and the size would be nil? Oh, or which side would be nil? I guess the P1 could be nil if we already have an empty hand. Okay. If maybe we'll add this check here where we kind of skip everything if those are nil, because that's going to then lead us to our termination case at the bottom where we can determine which of the players wins. Now it's running. It's taking a little while, which makes me think we're about to hit some sort of stack error because we're stuck in recursion. Oh, recursive game detected. I mean, I'm glad it told us that, but I'm not expecting that to actually be. What is the winning? Yeah, I mean, they're not giving us any indication that we can expect the. Oh, okay. If the game ends by that recursive termination happening, then the winning player will be player 1, so we need to get their deck then. So yeah, we're gonna have to rescue that. So let's see, begin, rescue, and in here, we don't need to do anything. I mean, maybe we'll say puts win goes to player 1 for hitting recursive loop. So at this point, we'll say final hand gets hand 1.cards, and we'll sum up our result. Give this a minute to run. Hopefully this will give us a number here in a second, once it's been able to rescue and resolve. 5724. I don't know about that. Yeah, that's too low. So it goes from round 1 to spawn it? Okay, so this seems right here like the issue. Why are we immediately spawning a sub game? Okay, so that logic must be mangled. Oh no! Greater than or equal to. That was a huge typo. 291. Yikes. File.read. Input 5586. That doesn't seem right either. Well, yeah, it's too low. Oh, I see. Any given, oh boy, okay. So any given round here could, any subgame could end in a recursive game, at which point that shouldn't bubble all the way up, but that player should just have won that game. So this rescue logic here needs to be applied I guess down here. So we say begin, say rescue. And so then set game result gets whatever returns from this block. And so we either return result or we return player 1 wins. Okay. And then we'd keep playing, I guess. Oh, and so subgame result is what needs to go here. Okay. Now let's try that. No, can't be coerced into integer. Line 87. Sure. Those numbers are going to be off now, but that's okay. There, we're getting a little more gameplay out of this. We're not just bailing in the second round because our error bubbled all the way up. Feeling a little more positive about this. It seems like it's actually playing the game now instead of that early termination. This is taking a while though. We get to a result. It's 5 figures, which will hopefully be a little closer to what they're looking for. 35436. And we got our second gold star for the day. All right. Thanks for bearing with me on that, and we'll see you for day 23.